Good afternoon, ladies and gentlemen. My name is Ijoma Ucheitete, and we're here representing Nile University. On behalf of the management and staff of university, we say thank you for this opportunity. As a way of introduction, Nile University is here in Abuja, and we offer both undergraduate, postgraduate, and short courses under our Nile consult. Our lectures are very flexible or are scheduled for flexible timing, usually from 5 p.m. in the evening, weekdays, and on Saturdays, so it doesn't interfere with work. Also, for our undergraduate courses, we have a lot of scholarship opportunities and discounts based on merits, for your words. So you can please meet us outside for further inquiries. And we're here to demonstrate one of our projects. I will hand over to the engineer here to introduce the students and also to do the demonstration. Thank you very much.
Thank you very much. It's a pleasure to be among computer scientists. Without you, we don't have codes to run this hardware. So we hope that at the end of this presentation, we'll have some form of collaboration between research, academia, and the industry. So we have come up with, we are going to present to you a plant disease drone, an autonomous plant disease drone. I guess that you will want to hear directly from the students because this is one of our final year students projects. We have at least 4 of this kind in the Faculty of Engineering. And at the end of the presentation, we are open to listen to you, to collaborate with you. My name is Engineer Paul Michael Ukwe, and here is Musa Badaru. He's going to do the presentation. Thank you.
Good afternoon, everyone. Permit me to stand on existing protocol. My name is Musa Badaru Adeshegun. I'm a student of Nile University of Nigeria, studying electrical and electronics engineering. What I'm about to present to you now is our project, which is on the design and the construction of a plant disease detection drone. So the idea about this came about due to the recent, about 2018, when there was like the tomato outbreak of disease that caused scarcity in tomato. So we looked into the statistics, and it showed that 25 out of the 35 countries that are most impacted by climate change will be a lot affected by food insecurity and malnutrition. And looking into it shows that by 2050, there's a 20% increased risk in hunger and malnutrition across the world. So we looked into it, and it was seen that bacteria and insects the changing environment has caused an enabling situation for them. So to limit this on the farm stage itself, we designed this drone that is specifically made to tackle the disease, the early detection of the disease on the farm to prevent outbreak of diseases within the country. So the drone is designed on a system that is efficient and uses an algorithm to go around the farm to detect the drones and then send out a result to the farmer. I don't know, there's supposed to be a slide for the presentation, sorry. So like I stated initially, from the problem statement, the challenge is determined from the climate change that occurred around the world that affected how farms can operate. So this challenge caused a reduction of 20% in plant yield across developing countries, which results in about a $200 billion. Sorry, let me just do this. which results, okay, yeah, which results in about $20 billion loss of crop yield by farmers. So continue. So next one. So the solution is the drone, which gives out an efficient system to go around the farm and capture the diseases on the farm at the early stage. Next slide. Who's in charge of the slide? Then next we have, after the solution, we have the next slide, please. The project incorporates an unmanned aerial vehicle designed to fly autonomously to go around the farm. The drone incorporates a series of sensors that are to work collaboratively with the software created, the AI software created, determined to detect the disease on the farm in the initial stage. So on the next slide, we have the block diagram, which shows the interconnection between the different systems on the drone. So we have the battery, which is the power supply of the drone. With the sensors, among the sensors, we have the ultrasonic sensor, the camera, which takes the video and images of the plants on the farm, the barometry, the altimeter, and other sensors that work in conjunction with the flight controller. The flight controller then receives the command from the companion computer. A full description of the operation is shown on our flowchart, which shown this at the start of the flight. The drone starts, and then the location of the farm is mapped out based on an algorithm given into the drone. So this mapped out location using the algorithm determines the flight pattern of the drone over the farm. Next, as the drone flies over the farm, it takes the videos and images of the plants. And these videos are passed through an AI system, part of which is present on the drone itself, to detect the particular plant that is present on the farm, and then detect what type of disease that particular plant has. Incorporated with this are some of the sensors I mentioned before, which is the ultrasonic sensor. As the drone is flying over the farm, the ultrasonic sensor is there, and the ultrasonic sensor and the LiDAR sensor are there to detect objects on the farm. So to take evasive maneuvers in the case in which the drone encounters a tree or other unforeseen objects on the farm. So the drone, when it encounters an object, it avoids the object and continues on the pre-planned flight as it transverses over the farm. These images are then sent to the AI system to detect the presence of the disease on the farm. And the drone now goes back to its base location and lands and processes the information and sends out the output to the farmers. Next one, please. Next slide. Yes. So we have a demo of the product working. The drone was designed to be operated outside, and the environment within this hall was not conducive, particularly in terms of safety, to operate the drone. So we will show you a demo of the product, if that is allowed. Sorry. My name is Musa Badaru. I'm a student of Electrical and Electronics Engineering at Nile University of Nigeria. We are working on a plant disease detection drone. It's a system that is meant to fly around the farm and detect the disease present in a farm. So the system consists of two models, one for the plant detection and one for the disease detection. Right now, we'll show you how the drone is supposed to fly around the farm and how it works during the operation. So for the operation of the drone, we have already inputted the coordinates of the farm before the flight. So to start the flight, it goes to the first corner of which the coordinate was entered. Then it flies to the next corner. Based on the algorithm we use to detect the fly path, it has a minimum viable point in which it detects, it designs and chooses the minimum distance between the points it's supposed to take. So now it's going to the end of the farm there. Then it's coming like this. It's going to come left then come back down. So that's the process of transversing over the farm. So the distance it moves like this is determined by the minimum viable point. Once it gets there, it's now going to come back. The motion is coming back right now. Okay. And it repeats that motion back here again and goes back there. And it completes that until it has transversed the whole area of the farm. So what you are seeing now is just that in operation. And it has gotten to the second end. It comes like this. It comes towards us and it goes back to the other. So as it's flying over the farm like this, there's a camera within the system that is facing the plants, and the camera takes the pictures of all the plants on the farm. So within the Raspberry Pi, we have the plant detection system that detects the particular plant the farmer wants to work on. That will now pass through another model that now detects the disease, and this will be done after the flight. But it's about to complete the mission, and it's supposed to land. So after it lands, the output of the model to the farmer is an heat map, which will show the farmer the location of where the plants are. And it's an interactive way for the farmer to get to the final place and put any contingencies plan to prevent the spread of the disease. So the market relevance of the drone is, the drone was designed for farming large areas of land which are used for farm, like a farming community with a lot of medium to large scale farm next to each other. So the drone can be utilized by different farmers within those communities to detect disease in the early stages and prevent the spread of the diseases. So the prototype has an efficient cost, as efficient as possible for the farmers to use. And the application of the project has a high cost to benefit ratios, especially for medium to high scale farmers. This is the next one. The next one, please.
Is it possible to move the drone? Okay. Is it possible to move the drone?
To fly the drone? Yes. Yeah, that is what I'm saying. Like, we can't fly the drone in here. It needs, like, how do I put it? A minimum, like, it needs to be very accurate. So it's for outdoor use, yeah, where you can connect directly with the satellites. In conclusion, the application of the project could help minimize the loss of plant yield to diseases a lot on the farm, and could prevent the occasion of 2018. Occasion of 2018. It prevents the reoccurrence of the occasion 2018 where there was a very high tomato scarcity within the country. This is promoted at helping monitor the health of the farm, of the plants on the farm, and to help grow the economy. So part of what we hope to achieve with this is are the SDG goal 2, 8, and 9, which are to help zero hunger, decent work and economic growth, and infrastructure, innovation, and industry. These were what we hope that this project will bring about in the country. So thank you very much for the presentation. And Nile University is here and always ready to collaborate with the industry and academics and research to bring this project to life and make it a product viable for the use of farmers. And for anyone interested, the drone, in a few minutes, we can fly the drone outside to show you the drone actually works, not just in the demo, and to demonstrate the amount of effort and hard work you have put into it. Thank you very much, and thank you for your attention.